This is Advanced Algebra Lesson 8.8, Solving Equations with Radicals. The big idea of this lesson is to solve an equation of the form x to the power of m over n equaling k, where m and n are integers. We take the nth power of both sides, but be careful not to change the number of solutions to the equation in the process. Because the radical involves the nth root, we can solve an equation containing only this single radical by raising both sides to the power of n, or to the nth power. We're going to use the example found in your textbook on page 562. It's example 1, and it involves spinning a ball in the string around a circle. If the string breaks, the ball will follow a straight line path in the direction it is traveling at the time of the break as shown below in this example. So we're going to use the equation velocity is equal to the square root of t times r over m, where t is the tension on the strings in newtons, m is the mass of the ball in kilograms, and r is the length of the string in meters. And we'll refer to the diagrams below. What tension is needed to allow a 4 kilogram ball in a 2.5 meter string to achieve a velocity of 12 meters per second? So we're going to take our equation that we have here. We're going to insert the value of 2.5 in place of the length of the string. We have 4 kilograms for the mass, and then our velocity is 12. So in order to solve this, we need to first get rid of this radical. So to undo this and the second root, we're going to raise everything to the power of 2. So when we do that, we end up with 12 squared on the left, and the radical is now gone, so that leaves us with t times 2.5 all over 4. I can multiply both sides by 4 and divide both sides by 2.5, and that leaves me with t alone. So if I take 12 squared times 4 divided by 2.5, that leaves me with 230.4 newtons. Now sometimes we have a situation where extraneous solutions may occur. Sometimes our original equation or our new equation may have more solutions than the original equation does. So we have to be very careful to check our solution with the original. Here's an example. I have an equation 12 minus the 4th root of x equaling 20, and I want to show that it has no real solutions. So if you start to solve this, we know we need to move 12 to the other side, so that would leave us with the opposite of the 4th root of x equaling 8. We then could divide by a -1, so that leaves me with the 4th root of x equaling -8. The 4th root of x raised to the 4th power gives me -8 to the 4th power, and that equals 4096. But if I go and check that, 12 minus the 4th root of 4096 does not equal 20. So 4096 is not a solution, it's extraneous. The equation 12 minus the 4th root of x equals 20 has no real solution. Let's take a look at the next example here. The last part of this lesson is working with equations with the distance formula. The distance formula has a radical in it, has lots of squared terms in it, so it's a perfect time to use this formula to hit at some of the concepts that have been discussed during this chapter. So we know the distance formula is this d equals the square root of the difference of my x values squared plus the difference of my y values squared. So when I'm working with this first example here, find coordinates of 2 points on the line with equation x equals 3 that are 10 units away from the point. So here's my point, -4, -2. And I need to get 2 points on this line that are 10 units away. So I'm going to use my equation from above. I'm going to call this my x2 and my y2. So those are going to go into my formula here. I also know that my x coordinate is going to have to be on the line x equals 3, so I know that's going to be one of my value for x, so I'm going to put that in there. I don't know my y value, that's really what I'm looking for. So now when I go about doing this, 3 minus the -4 is 7. If I square that, I get 49. and then I end up with y plus 2 squared. And I don't want to deal with this radical, so I squared both sides kind of all in the same time. 49 has to move over here, so that gives me 51 equaling y plus 2 squared. I don't want this squared here because I need to get y by itself, so now I'm going to unsquare it by taking the square root. So I'm going to take the square root of 51. That would be the plus or minus the square root of y plus 2 squared. We know that the square root of something squared is that something, so y plus 2 is going to equal the square root of 51, so I'm going to move 2 over, so that leaves me with y equaling a negative 2 plus or minus the square root of 51. Then when I go ahead and get an approximate value, a negative 2 plus the square root of 51 gives me 5.14. Negative 2 minus the square root of 51 gives me a negative 9.4. Since I know that my two coordinates all have to have a negative or a positive 3 for my x value, because it has to land on the line y equals or x equals 3. So then I can use my other two for my y values, and here are my 2 points that would be 10 units away from my negative 4, negative 2. This concludes lesson 8.8.